There are occasions when we will see a quadratic equation in a slightly different form, or at least starting out in a slightly different form. This proportion example that we have here is an example of exactly that situation. You probably learned in pre-algebra or algebra 1 that when you're solving a proportion, the most efficient route for solving a proportion is to cross multiply. That strategy does not go anywhere the more complicated the equations get. If you have a fraction equal to a fraction, cross multiplication is a quick and efficient way of cleaning out the fraction bars and resetting into an equation that doesn't have any of that division in it. So that's exactly what we're going to do here. We're going to multiply x minus 7 times x, and we're going to multiply x plus 5 times negative 1. X times x plus 7, negative 1 times x plus 5. We have variables on both sides, so naturally your inclination would be to try to isolate the variable to one of the sides, but unfortunately, because of the distributive property over here, we have that square term that pops out that we're going to have to handle in a slightly different way. Negative x minus 5. Because we have this quadratic, we want to set this equation equal to 0. It's always easier to go the way of the quadratic, especially if it has a positive coefficient up here. So because that coefficient is 1 in front of the x squared, we're going to move everybody from the right-hand side of the equal sign over. So we'll keep the x squared. We'll add the 1x to the negative 7x and get negative 6x. Then we'll add the 5 over, and all of that equals 0. We're looking for two factors that multiply together to make 5 and add together to make negative 6. That's pretty obviously negative 5 and negative 1. Embracing again the zero product property, one of these has to be equal to 0. So in order for that to happen, we have either x is equal to 5 or x is equal to 1. And if we write our solution set, we get 5 and 1. It's never a bad idea, especially in these kind of equations, to take these answers back and check them to make sure that they work. In the case of 5, we have, subbing a 5 in, we would have 5 minus 7 over 5 plus 5 equals negative 1 over 5. And that checks because the left-hand side makes negative 2 over 10, which is the same as negative 1 over 5. And if we were to check the other answer, we'll say 1 minus 7 over 1 plus 5 equals negative 1 over 1. And this is negative 6 over 6, which is the same as that. And that's also a check. So both of our answers, both of our solutions worked, and we solved them by using a very tried and true process that you're probably very familiar with, cross multiplication.